Okay, so my name is Andrea Barisani. Actually, well, my name is Andrea Barisani, but when I speak in English mode, I cannot even pronounce my name properly. So I'm Italian. He's Daniele Bianco. We work for a company called InversePath, and we're going to talk to you about injecting RDS TMC traffic information signals. So how to freak out most European satellite navigation system, in-car navigation system, and US and Canadian ones as well. So as you can see, we got a bunch of equipment here. We're going to try and show you a small demo of the stuff. We're not sure if it's going to work because when you travel within the States and you bring this kind of equipment, you usually get one of these, which is a TSA notice of baggage inspection. And so they, they broke some stuff. So hopefully it will work. But anyway, we'll try. So what's this thing about? So modern in-car satellite navigation system are capable of receiving dynamic traffic information, okay? And one of the systems which is used within Europe and North America is called RDS TMC. So basically what happened is I bought a car which had this system on, and of course my first thought was, this could be interesting. I could hack this thing, okay? So that was the first thing that came up in my mind, and then of course I drove the car and it was fun. And anyway, so we show how it's possible to easily, I wouldn't say trivially, but I mean, it's very easy to hijack this kind of information and do some very cool things with this kind of protocol. So hardware hacking is fun, and of course, the concept of owning a car is priceless, so that's what motivated us. Since we're playing with FM radio transmissions and RDS, which is the radio data system, it's very 80s, so it felt very, very cool. And the main problem is that this kind of information is implicitly trusted by drivers, okay, and is, sent in almost clear text. So we found, that's a problem. So let's try to make a presentation about it and get free tickets to, all around the world for doing conferences, and it worked. And more important, chicks will melt when you show this, and we're going to prove that with a very effective video, okay? So that's the important thing to us, really. It's not hacking, it's chicks. So radio data system. So RDS is used for transmitting data over FM transmission. It is the protocol that allows you to see the name of the radio station on your car display. Okay, so 100% of FM radio nowadays support that protocol. And it can also be used for other things like alternate frequency. So you're driving, you're setting a radio station, and that, you're passing through a different state or whatever, and then your radio automatically picks up the new frequency. So that's called alternate frequency. You get a program type, so you know what kind of program is being played. And on most radio, you can set, I want to hear country music or whatever. It's not very much used, but, it's there. You can get the time, so it's a poor man's NTP service. And you can get a news override. So what happens is when you're listening to your music CD, you can tell the radio, okay, just stop playing the CD and, fall back on radio because I want to hear the news, okay? So what happens here is that RDS, so this is like the FM spectrum. So we have a mono signal here at the 19 kilohertz subcarrier, we have a pilot tone. Here we got the stereo information. And here at 57K, at this subcarrier, we have the RDS signal, okay, which is basically bits going on, 0 and 1. And your, radio is focusing on that subcarrier for getting the data, okay? So RDS TMC is a way for using RDS, for using that subcarrier to send, information about traffic, basically. It was first introduced in 1997 in Germany. Of course, who else could have introduced that? Germany. And it was implemented around Europe in the following years. And it's kind of old protocol, but for instance, Italy got it in 2004, and Australia will get in this year, okay? So even if it's very, very old technology and very 80s, I mean, this is actually very, very relevant. And it's a technology that's still being used, and it's been pushed right in the, last 2 or 3 years. So what happens, we got, stations, police, whatever, getting traffic information, and then they send this information to radio station, okay? And this radio station, they broadcast this information in packets, in RDS packets. And then on your car, if your satellite navigation system supports that, then you're going to see the information, okay? So it's implemented in almost in-car satellite navigation system. If you buy a car which already has a navigation system, you usually get TMC functionality. If you buy external or portable RDS system, satellite navigation system, you can usually, if it's a low-end model, you can buy an external antenna so that you can get the feature. On high-end models, it's built in. RDS TMC is available in both free and commercial services. Most of the services is free, so you don't have to pay anything for this. And we're going to see what we refer to when we talk about commercial services. Okay, it can also be transmitted not only over RDS, so TMC can also be transmitted over digital radio. Okay, so some people do that. So this is our RDS TMC terminal. So this is my car, and here we get the event list. So we got a cute icon about the category of the event. We got this is a road name, and then we got how far it is from us. So 215 kilometers. And then if we click on one of the events, we get a map with the road and the event and a nice label for that. Okay, so you can browse through all the message events, or the car is going to pop up events. We're going to see when that happens. So the issue is that there's no form of authentication of the data. There's some sort of encryption which is supported, but it's only used for discrimination of messages. It's not really used for security. It's not real encryption. It's just something we're going to talk about that, but it's only used for commercial services and is completely irrelevant to our goals. Okay, there's no session involved. There's no concept of sequence number or stuff. It's just plain text, clear information. So we tested the feasibility of decoding, so understanding the protocol, and sending false messages to our victim by using off-the-shelf components. We didn't want to spend thousands of dollars for doing this. We just want to show, we can do this with, $100 of equipment and it works. Okay, and so you'll be the judge of our results. So this is the victim. So in most presentation about IT, you got the victim and you got like a box or a server. I mean, here you got a freaking car. Isn't that cool? That's what motivated us the most, okay? And so the first thing we need to do is sniffing RDS for understanding what's going on, okay? So we need to get a raw FM signal, which is called the MPX, okay? And the way you can do that, you get an audio or video tuner, a PCI board for your computer that also acts as a tuner. You can buy that for $20 on eBay, okay? And most of them have an FM decoder module, which allows you to pin in on the board and get this raw signal. Because we don't want the audio component of the signal. We want the raw information before it's being processed by, our soundboard and the speakers and stuff. And so here you can get a list of all kind of chipset you can get. And this one, so we use this one. So we bought we looked for a car that has that chipset, and so which was useful for our goals. Okay. So once we have the signal, so we need a chipset that can demodulate the RDS signal, and that's one of the most common ones. Pretty much every radio that decodes RDS information has that kind of chipset. Okay, there's one or two chips that do that. And then we use a PIC for serial conversion, and then we decode the signal using our own software so that we can actually see what's going on. So think about Ethereal or Wireshark for RDS, okay? And so we use custom hardware for that. And there's another project going on that tries to do this, but it's very outdated. It doesn't concern TMC messages. It wants a specific set of equipment, so it's promising, but we decided to do our own thing because it was better. So this is a standard PCI board for audio and video tuning, and there we can hijack, the board and get the raw signal. So for sniffing, so this is our chipset. So do you want to talk? Because you're speaking as well, You can't get away with this without speaking. Or you're busy. Okay.
No, I can't.
Okay.
No, I can speak.
So go on.
Setup. It's pretty simple. Okay, as Andrea told, we get the MPX signal from our tuner. Our analog signal go to the TDA 7330B, that is Basically, it's an RDS demodulator chip. It's from Philips. We use a microcontroller, a programmed microcontroller, just to prepare the digital signal from the demodulator, just to prepare the digital signal for the serial port, from the PC serial port. Okay, so the main components are the demodulator, the programmed microcontroller, and the MAX232, that is an inverter that has a function to invert the signals from TTL electronic 0 to 5 volts to 0 to minus 12 volts to plus 12 volts.
So this is the board. It's very tiny. This costs like $20 or something like that?
Yeah.
Okay.
Yeah.
And if we can make it, which we have basically no manual skills because we type on the keyboard all day, anyone can make it. So,
so that's what.
That's the assembly. So
Yeah.
as you can see, we built our own lab for. No, go back. I wanted to show important features about this. Go back. Okay. So this is used for printing the board. As you can see, our lab is so advanced that we have a bed nearby so that we can attend the process. Okay, so we are nursing this board, and so that's how it works.
Okay,
it's a very creative process.
So that's another diagram of the sniffing circuit. Okay, that's.
So if you want to do it by yourself, you got all the information you want.
Pretty simple. Okay. So why we use the microcontroller? We use the microcontroller because for two reasons. The first one is that we want to timing correctly the signal for the serial port, and the second one is that using the microcontroller we are able to discriminate the quality of the reception, and so it's very useful for our purposes. Because we are able to understand if the tuner is well tuned or not. Okay. This is the output that we get on the serial port. So we have the digital RDS stream, zeros and ones.
So this is not a very good one because we can see there's not lots of zeros and ones. Okay, so this was just with a very crappy antenna. Okay, and then when it works better, you get a proper stream of data. Okay, and it's binary, so it's cool. Okay, so forget assembly. We're just reading binary from air, so it's wonderful. So just to show you what we're talking about, so this is the RDS protocol. It's very, very simple because it's made to be very space efficient because we don't have much bandwidth, okay? So basically what we have, it's composed of 4 blocks, so it's 104 bits, okay? So a block is made of 2 sections, 16 bits of data and 10 bits of a check word, which is like a checksum that's used by radio to actually to validate if the message was good or not. Okay, since we're talking about radio transmission, I mean it's very easy for a 0 to get a 1 and for a 1 to get a 0 because of static noise, weather conditions or whatever. So the check word is an attempt to try to do a checksum control on that. It doesn't work very well, but it's still something. So on the block 1 of every RDS